Hello. In a previous post this month, I wrote that VBA does not have reflection that could allow some fancy dependency injection mechanism. This is strictly true of VBA itself, but VBA is a COM artifact, and reflection interfaces are available as part of the vulnerable COM specification. Luckily, with the help of some Python, we can call some of these reflection interfaces on a VBA class. Now, I have to give you a warning. There is no warranty for the code in this blog. What follows is a little known technique which I have not put into a production environment, so I can give you no warranty. So you must you use it at your own risk. There's no warranty is given for any code in this blog post, nor for any of the blog posts. But if you do choose to use it, then do please let us know how you get on by leaving a comment below. So what is the high-level use case? Well, in this post I'll show enough Python reflection code to drive a better dependency injection mechanism. The high-level logic is easy enough to express. All I need is to check a VBA class instance for a certain method named inject dependencies, and if found, return a list of argument names which will determine what to inject. Seems simple enough, but it requires delving into COM reflection interfaces, which are typically unknown to a VBA developer. So what is the strategy? Strategy will be to acquire a pointer to an I-type info interface, which is a COM reflection interface. We're calling that from acquiring that from a iDispatch method, and then calling methods on that I-type info interface. So I have a diagram. In the diagram, the left-hand box shows the virtual function table of a VBA class. The class only has 3 user-defined methods, foo, bar, and baz, but as it is a COM class, it also has an implementation of IUnknown. Also, because VBA classes can be late bound, we know they support iDispatch, the methods of which come after the methods of IUnknown. Then come the user-defined methods. So foo is in fact the eighth method in this virtual function table. Now I want to attract your attention to the iDispatch methods. Maybe you're already familiar with the iDispatch methods getID of names and invoke. These implement late binding. Less well known, I would argue, are the other 2 iDispatch methods, getTypeInfo and getTypeInfoCount and getTypeInfo. But I believe these methods deserve high praise and more attention as they return runtime type information. In fact, I believe these methods are what allow rich reports on the late bounds object properties in the locals or watch windows. Now, in fact, getTypeInfoCount is just a guard method which returns 0 or 1. The real method is actually getTypeInfo, which returns a pointer to iTypeInfo. And incidentally, a lot of these are hyperlinked, so if I double click on this, we get to go to the Microsoft documentation. Our code will acquire a pointer to iTypeInfo by calling iDispatch getTypeInfo. Now, we have to talk about dual interfaces and how there's 2 instances of iTypeInfo. Now, if you've worked with C# reflection classes, you'll probably smirk at the iTypeInfo interface, particularly in this next case. A COM class can have a dual interface, meaning it can either be accessed either by iDispatch or through its virtual function table or vtable interface. Thus, dual interfaces require 2 separate iTypeInfo interface instances. iDispatch getTypeInfo returns a dispatch iTypeInfo interface instance, but in the code we will hop to a second iTypeInfo interface instance, which is the vtable iTypeInfo interface instance. We have a couple of methods, these 2 methods here. Now please don't ask me to defend this API design. Given an iType info interface, one thing we do is we can get some type attributes. There's lots of properties here. We will be interested in this one, cfuncs. So for an interface, gives you the count of functions, where function is a synonym for method. Now the Python library will handle releasing these structures memory. So that's something that the Python layer will do for you. We don't have to worry about it, unlike if you're writing in C++. Once we know how many methods there are, we can loop through them and for each method acquire the function description structure or funcdesc. Again, the Python layer will release the structure for us when it's no longer required. From here we get the member ID for each method, and then we use the member ID to call getDocumentation. That will give us the method name. If we find inject dependencies, we will then take note of the index, and then data will come back, and we'll call getNames to return a list of arguments. So that's our strategy. So what follows is a Python com server, aka a gateway class. I have placed many examples of these on this blog. For those new to this will implement a com server that is creatable from VBA using createObject. In the class below, the code maintains a log because it can be quite difficult to communicate what is going on without a log. The strategy outlined above is implemented in here, read params. The first parameter is actually says self, which is how the class state is passed around. The first real parameter is this O, which should be an instance of a VBA class. Please do pass a real VBA class and not a document class such as this workbook or sheet 1. Also, for the VBA class, the instancing needs to be of type 2 public not creatable for reasons I've yet to confirm. So we're going to be working with this tax calculator class. And here you see the instancing. On VBA you have choice of 2, you have either private or public non-creatable. You need to set this to 2. I've yet to firm out why, and hopefully I can post about it once I know for certain. Well, once you pass in an instance of O, then you should be able to see that there's some the opening lines are some type checking, which is just some defensive code. The real line of code that gets going here is this get type info, and for this, what is returned here is a type info pointer. The rest of the code then follows on from the strategy above, so hopefully you should be able to follow it. Now, if you've written .NET reflection code in C#, then you are lucky. It is very intuitive and easy to understand. The COM reflection interfaces, however, are far from intuitive, in my opinion, especially if you're writing in C++. The COM reflection API can be quite painful, so do be thankful that some Python contributors, Tim Golden and others, have added a layer to insulate you from these C++ complexities. For more information, you can look at the Python document. Now, upon rereading my code, I think perhaps I may make it slightly tighter by removing a number of lines. And also, I think we could quit the loop earlier, but never mind. Finally, on a COM interrupt note, Python tuples need to be converted to lists for passing back to the calling VBA, where they are marshaled to a variant array. So that's why this getNames, I think, returns a tuple, which we then splice because we don't need the first element, because that's a duplication of the method name, but it's all passed to this list constructor. Getting the right return type is important. Make sure it's a list if you want a variant array. Now, we're going to be dealing with a VBA class. We have a business logic class, which is the sort of thing that's going to want some dependencies injected into it. So here it is. Here's the listing. And so that's this class here. Then we have some calling code. Let's look at that in the VBA. So we want to return a list. This first line just returns default list. That's not terribly of interest here, but here's the real first line of interest. We say create object, and this is the prog ID. So let's just go look at the Python listing. This is Visual Studio, and you can see this is the prog ID here, and it's this is a Python com class. It's a gateway class, and it says we register these methods as part of its interface. Now, in order for this to work, you must run it from the command line once, so that the main method is executed at least once, because the main method calls the register method, and this is how the class is registered into the registry. But you only have to do it once. After that, then you can create this object, and then you call into read params. So we create the object, and then we clear log. Here we go, read param. So we've passed in an instance of a VBA class. Here we've got the test. So we create our tax calculator, and then we're going to pass in the instance of the tax calculator into here. Let's just see what happens. So it's gone off and it's done its reflection, and it's identified that it's found this method of inject dependencies, and then it's found the list of arguments. Let me just add that one to demonstrate that this is in fact dynamic. There we go. And one more time. So you can see that this is working. So we have effectively implemented reflection in VBA, not necessarily in VBA itself, but via some C++, via some COM interfaces typically intended for for use by C++ developers. But thanks to Python developers and open source, we are able to acquire access to these interfaces via VBA by using a Python helper class. Thanks for watching.